right.
Sampling is in progress.
How
Thanks so much.
how difficult is a project like this to carry out? The asteroid is the size of a skyscraper. It sounds like it would be very, very precise.
So it's extremely challenging for many reasons. First of all, is you have to accurately get something which is about the size of a small car to a distance that is twice that from the Earth to the Sun, so very far away. And you have to precisely be in orbit around this small body, and then you have to land something on it. And what I find incredible about this mission is it wasn't that they were just plopping down the lander on the surface of the asteroid. They were actually doing something called a tag, where they briefly extend this robotic arm, inject nitrogen gas into the soil to disturb these particles, capture them, and then there it goes. The spacecraft is off again, taking away from the surface. So it's not an extended landing, but a very quick kind of grab, if you will. And then hopefully we'll know soon, within 24 hours, if it did collect enough sample from the surface to be able to return early next year.
So what do we know about this asteroid already, and what scientists might be able to learn from it?
So asteroid Bennu is very interesting because it's what we call a carbonaceous asteroid. And as we know, carbon is very prolific in our solar system. We're mostly made out of it. And what we see with this asteroid is that it actually has signs that the larger body that it broke apart from might have had liquid water within it. So very similar to the dwarf planet, which we call Ceres, where we know now that there's probably water under its surface. Bennu could have come from a very similar kind of parent asteroid. And that's exciting for us because if we detect materials with water in them, it could be signs of primordial life. But even more importantly to us right now, actually, or just as importantly, is the idea is that we could use these kind of materials for future spacecrafts. And so we're talking about mining asteroids for fuel to enable us to go even further and deeper into space.
You know, you'd mentioned the process of gathering that sample from the surface of the asteroid, this touch and go sample gathering. Talk to us a little bit more about that, and why was that used, and why couldn't the probe actually land on the asteroid?
So, as we've seen with other missions, such as the Philae lander, having a really robust landing where you can stand for a long period of time and collect material and then launch off the site, it's very dangerous. And so, I mean, you know, obviously diving in and scooping off material and flying back out also has its challenges. But I think the idea here was because it's a sample return, you wanted to have this new and innovative way to quickly be able to disturb the surface. And I think it's very interesting. You're not seeing something sitting down and drilling in, but is very clever to use this gas to disturb the surface, which we believe is very diffuse and kind of lightly distributed particles. And so it wouldn't take much to disturb that and capture it. So you wouldn't really need to set something heavy down on the surface and drill down into it. And this is not unlike what we saw done with the Hayabusa probe, the Japanese probe, which has now twice landed on asteroids to collect samples, where they did a similar thing of firing gas into the surface of the asteroid to disturb that light outer material. And the landing site itself is interesting because they do believe it will contain, it's a newer kind of region of the surface. So like on Earth, where we see volcanoes erupting and areas being weathered down, that can happen with asteroids out in space where all of the cosmic radiation affects the surface. And so this landing site, they think, is a bit more pristine. And so then hopefully they were able to gather some of that loose and very interesting material.
All right, all very exciting. Rebecca Allen in Melbourne, thank you so much.